you. So I'm Chad Granum. I go by Exodus on IRC and CPAN and other Perl circles. And I'm going to be talking to you about Test2. My presentation is not your normal slide presentation. This is an online manual for Test2 that is designed to be used both as a presentation material and a source. So please do follow along and feel free to visit that site. It's up right now. So Test2. What is Test2? Test2 is a complete reworking of the testing infrastructure that started with Test Builder. It has gone through many different phases. It's been called Test Stream at one point, Test2. At one point it was going to be a full refactor of Test Builder, and at another point it was a full rewrite. So it's gone back and forth a few times. But why? The reason is because Test Builder has been around for about 10 years, and it really wasn't designed for all the things that people are using it for. And at this point, there are some test modules out there that will take the singleton, which is at the core of Test Builder, and re-bless it out from under you, or just completely change all of its internals with direct hash access. There's just a lot of things that tool builders wanted to do that Test Builder did not make easy if it was possible at all. On top of that, Test More itself even had to really fight Test Builder to implement things such as subtests. The subtest implementation in Test Builder would make you cry. It is pretty bad. So what's going to happen to Test Builder? Well, it's going to stick around, it's going to continue to work, but it has been changed. It has been changed so that it now uses Test2 under the hood. What this means is that all your old test tools, all the ones you've been using, all the ones that are out there now, will work nicely with your Test2 tools. There are very few exceptions to this. The one that re-blessed the singleton, for instance, that one won't work. Moving on. So let's talk a little bit about performance here. With the change to Test2, there was a fear that it was going to be much slower because it did, or does, a whole lot more. But these benchmarks show what the actual speed difference is. Now, load time, Test2 is nowhere near as fast as Test Builder. It just can't be because it is much bigger. Test Builder was just one module. It was something like 500-600 lines long. That loads very quickly. But despite everything it does, Test2 doesn't take very long to load. You see the difference there, 0.01 versus 0.027. It's not that big of a difference. The exception is that if you are running a lot of very short test files, like we're talking the Perl 5 test suite, that does add up. But thankfully, the actual runtime of Test2 is significantly faster than Test Builder's was. And even if you use Test Builder tools on Test2, they're going to perform faster than they did under the old Test Builder. All in all, these two differences balance out. The Perl test suite takes roughly the same amount of time to run. The Moose test suite, roughly the same amount of time to run. The startup time does win out overall, so it is slightly slower, but most people will not notice because it's like a 5-minute run, it's 10 seconds slower. So let's go over some of these numbers here. I'll use the mouse so I don't walk away from the microphone here. So Test Builder Legacy, that's the Test Builder that you were using before Test2 came out, running 100,000 OKs in a loop, just over, almost 4 seconds. Test Builder with Test2 shaved off, 600, don't know, is that microseconds, milliseconds? Bad with my units there. And then if you just use Test2 based tools without going through Test Builder at all, it's almost twice as fast. And then threads, it's the same story. Test Builder with threads, pretty slow. Test Builder with Test2 and threads, also pretty slow. But Test2 with threads actually runs faster than Legacy Test Builder without threads. And I say threads, but Test Builder only knew how to work with threads. It didn't know how to work properly if you were forking or using other forms of concurrency. Test2 does. If you are using Test2, you load something called Test2 IPC. Threads work, forking works. You can use both at once, and it just works. It knows what to do. And it's significantly faster while it does it. So I'm going to start here by going over a tutorial that's basically an introduction to testing, but using Test2 instead of Test More. But first I want to gauge roughly the experience in the room to see how quickly to go through this, because we might be able to get to some more technical things if there's time. Who in here has written unit tests in Perl? Okay, how many of you use test-more to do it? Okay, how many of you have written a test tool using Test Builder? Okay, a fair amount. How many of you have already started using Test2? Okay. How many of you have recently upgraded the Test Simple disk so you get Test2 for free? Nobody. Ouch. Okay, well, surely you have.
But not for that reason.
Okay.
I would use Test2 directly.
Yeah. Okay, so like I said, with Test2, all your old test stuff will still work. There is no need to upgrade your tests unless you used one of the very tiny fraction of the modules that don't work with it, and you probably aren't. But, where's it going with that? Okay, if you want to use Test2 directly, though, you want to stop using Test-more. You want to stop using Test Simple, and there are a few other test libraries out there you'll want to stop using and use alternatives instead, because when they are built directly against Test2, they have better diagnostics, and they just work much better and faster. So with this tutorial, you'll learn how to write a test file, how to set the plan, make assertions, do some advanced comparisons, which I think some of you are going to like here, and then how to do to-do. Most of this is going to be beginner stuff, but we're going to move past this pretty quickly. So your boilerplate. I recommend you use Test2 Bundle Extended. This will load everything I recommend you use. So that's several plugins, several tools. It'll turn on strict and warnings for you, though you can ask it not to. It's just everything you need to get started. This boilerplate, I put a little notice on the bottom. This will not pass if you just do a test file with just this because there's no assertions. You need to have assertions. So moving on. Why do you need a plan? A lot of you already know this, but the idea is that if you're running a test script and it just outputs a bunch of OKs, it's possible something you call might just exit 0 suddenly, and then the rest of your tests will not run. And so some of those tests could be failures, but you'll never know. So the reason we have planning in testing is to ensure all your test files run. It might seem like, oh, duh, but there are people who just didn't get this, and they'd say, oh, no plan, I don't care about a plan, don't want to count my stuff, oh, I don't want to bother putting done testing at the end of the file. The plan really is important, because you really don't want tests that don't run. So, counting. This is the old way, the original way testing was done. You would just say, hey, I plan to run 5 tests. This is annoying, you have to change it every time you add new tests, and if you do tests that are dependent on conditions, you might have a different number each time. So done testing was added a long time ago, and that's what most people use today. It counts for you, but you put it at the end of your test to make sure they have all run. If something exits 0, done testing is never encountered, your plan's not reported, and you know your test didn't finish. It's really important that you do this. You could also skip all. This is something that's done a lot. Sometimes you have tests that will only run on one platform, like tests that only run on Windows or tests that won't run on Windows. It's important that you be able to skip them. Skip all will set your plan to be skip, and then it will exit immediately. So none of your tests will run. It's really good if you have a test that'll segfault on certain platforms. So assertions. This is the key to testing. You make assertions. You say, this code does what I want it to do. So here, you use the OK function. The OK function takes a Boolean for true or false, does this pass or not pass, and then a name of the test. Just something anyone here who's used Test-more knows, so you all know it. I don't have to keep going through that. Comparisons. This is where there's some differences here. Test2, the tools built on Test2, which are a part of Test2 suite, I think I forgot to mention, there's no longer an is deeply. Instead, you just have is, and it's smart enough to do the deep comparison for you. And the way it works, you've got what you got, the first argument, and then what you expect it to be is the second argument. What you expect it to be is considered canonical. So if you give it a data structure as the first argument, but then a string as the second, it's going to know that's wrong. It's not going to try and do a deep comparison because it knows you only wanted a string. That is why it is safe to combine is and is deeply, whereas sometimes it's not safe to combine tools because it can't guess properly. With is, it is safe to do the combination. So here you can see we're comparing two strings, we're comparing two arrays, and we compare two deep hashes. And then at the bottom, showing you an edge case, which is overloading, which is where you have an object that when used in string context returns a string. And you can see that this test will do the right thing, which is a very important thing to be aware of. The deep comparison, just like isDeeply, does not care if the things you pass it are blessed or not. It will not pay attention to the blessed, to whether or not it's blessed. Okay, like has also changed. Like is, you can, yeah.
I don't understand what happens on line 16.
Line 16. Are you familiar with object overloading?
Oh, that's like you've given it as your object has a stringification method?
Yes.
I see.
Okay.
And then you put the stringify there, okay.
Yep.
I understand.
And a lot of people used is for this purpose, so I'm putting this in here to say it won't break. You can start using the deep version of is, and your overloading thing won't break. Yep. Like is now a deep comparison. It is a deep comparison where it only checks the things you care about. This is a very often requested feature. So here's the old school. Go away. Like string apple should match the regular expression PPL. It matches. So your old use case still works fine. But let's do deep comparison. But we only care about the first two values of the array. It will only check the first two values. This will pass because those first two values match. Problem? That might be good. Okay, you can go even deeper though. Here we're comparing a hash. We don't care about A, so we're not listing it. B, we only care about the first two elements of the array, so we're listing those. C should match the cat regular expression. We don't care what the string actually is, and we also don't care about D. So this lets you do a deep check, but only of the parts you care about. So really, the difference between like and is that like is not strict, is strict. And once again, the right-hand side specifies what the comparison will be. There's also a domain-specific language where you can specify what you want with more control. So here we've got this big old data structure. We're saying we want to find an array. First item should be X, second item should be Y, third item should be this hash that has the field foo that should be bat. The field yikes should not exist. That DNE means does not exist. And we also use the end keyword to say, hey, there should be no more fields. Note, what we want and what we got are very different. This test will fail badly. And this is a way for me to show you the diagnostics messages that using this DSL will provide. It's like, oh, we got A at the 0th index of our array, but we were trying to use the equality, string equality operator to check that it's X. Note, it tells you which operator it was trying to use. So if you're trying to do a numerical compare, it'll say, oops, you probably wanted a numerical compare, but we're using a string compare. And it tells me your check was on line 4. How many of you have used isDeeply to compare deep data structures? It's like, oh, the first difference is here, and you had no idea what line to go to. If you use this DSL, it records the line numbers and tells you which ones were different. It also tells you all the differences, not just the first, though it will stop at 25 just so your screen isn't a nightmare. And it'll tell you that it did so. So we can see, yep, line 4, that check failed. Line 5, that check failed. Oh, our hash, line 10 failed. A note, when you span multiple lines like this array did, lines 3 to 11. The hash you specified was on lines 3 to 11. So these diagnostics are really nice. And here it's like, oh, yikes, we said we don't want it to exist on line 8. And oops, that shouldn't exist because we said, hey, no more fields. And so it's letting you it doesn't exist. In that case, it can't give you a line number because you just specified end. But these are the diagnostics you get if you use this DSL. And I can tell you, it is a lifesaver. Question?
So this pretty much obsoletes Test2?
Maybe. I've never actually used Test2. I found out about it after I wrote this, though. But based on what I've heard from some people who have used it, we both solved the same problems, but in a couple different ways, some similarities. Moving on. To-do is different. How many of you have used the to-do system that Test2 provides? So you localize to-do, which I don't actually have that code up, but you localize the global to-do variable, set it to a name, and then end your scope. That's kind of nasty. No one uses local much these days. So now to-do is a function. You have two ways to call it. You can say, hey, to-do, here's my reason, and here's a sub. Everything in that sub will be under that to-do. Once the sub's done, it's gone. You don't have to clean up. You don't have to think about the global variable. The other way that's closer to the old, which is good for porting, is you create a variable and call to-do and store the result. And once that variable is destroyed, your to-do ends. So it's just like the local one, except you don't have to mess around with local. Note, if you do load test more, the global to-do still has an effect, but it won't have an effect if you're using the test2 tools directly. So, the what's next, we're going to move on and we're going to talk a bit about the tools and plugins and other things that are available through Test2 Suite, which is the new tools built directly against Test2. So tools are...
Can you go back
to
comparisons slide?
comparisons.
Yeah, you gotta, the one with all the, there we go. Yeah, where it says badly, that should say beautifully.
Okay.
That is just fantastic.
Okay. So going to tools, we're going to talk more about the compare later on in this set here. So tools are anything that produces an event for the Test2 system. Unlike Test Builder, Test2 is an event-driven system. Every time you do an OK, every time you set a plan, every time you give a diagnostics message, this is turned into a proper event object. And the event gets sent through a chain that eventually, usually, gets turned into tap. Though that is not required anymore. You can output to anything you want. It doesn't have to be tapped. You just write a new formatter. You can also add listeners that will intercept these events. So being event-driven is really nice. It really gives you a lot of places to hook in for different behaviors. So you've got your basics, which is Test2 Tools Basic. This is included by the extended bundle. It's got all the ones you're familiar with. OK, pass, fail, diagnose, to-do, skip, planning stuff, all that. It does not have any comparisons, though. Is part of a different package. Question?
Can you inject your own events?
Yes, easily. And I'll get to that in the much more technical section if we get there. So then there's tools for testing your classes. These look familiar too. You've got is OK, can OK, and does OK. A note, is OK in Test2 is different from the one in Test Builder. What a lot of people don't realize, Test More. What a lot of people don't realize is OK in Test More takes a thing, a single class for it to be, and then an alternative name for the thing. A lot of people just pass in 10 different classes to say, hey, make sure this is all 10 of these, not knowing that only the first one actually counts. Is a major bug. I found a lot of people were doing this, and so I made it so that is-OK has the same exact calling conventions as can-OK, so that people don't get them mixed up anymore. You give it a list of things. Then I also added does-OK, which calls the universal method does, which is different than Moose's does, so be clear on that. Comparison. Note the extra section at the bottom just to go through all these. So the Test2 Tools Compare library provides is and like, isn't and unlike, which can't have the nice, diagnostic simply because they're a Boolean reversal of is and like. It either matches or it doesn't. Then you've got a bunch of helpers for the DSL. That is a lot of helpers. So there's the shallow and the deep compares again. I'm not going to go over those right away. So you've got some shortcuts for your DSL. You can say, hey, is thing true? Is thing false? Is thing defined? Does thing not exist? And false or doesn't exist, we don't care which. And all of these can be popped in at any level of depth, whether you're using an actual hash and putting these in as a value in the hash, or using the DSL to define your hash or array as a block. And you can just throw them in and say, for this field, whatever. And this works both in is and like. Is strict, like is not strict, but when it comes to one of these shortcuts, it will do the right thing regardless of whether you're in is or like. And I'm going to actually jump ahead slightly here. Oh, maybe not. Okay, no, I didn't want to jump ahead. Okay, you can do a regex compare in is now just by saying, oh, this should match this regex. Whereas like would automatically see the regex and go, oh, we want to match this regex. Is would see the regex and go, oh, this better be the exact same regex. But you can say, no, match the regex. Don't just be the same regex. You have mismatch. Please don't match this regex. You can say, hey, I want the number 12. It'll know to use a numerical comparison. So even if you give it something from a database that has the decimals, it'll go, yeah, this is the same. It can't automatically guess if it's a number because that's really bad in Perl. But you can say, oh, this one I do want to be a number. You can do the same thing for string, but string's the default, so it's kind of pointless. You can also check, hey, this should be the exact ref I'm looking for. So here, make sure that AR has the exact ref R. This can nest any depth you want. It'll just work. You can also do custom ones using validator, which lets you take a sub or $_ then the thing you're checking. Or if you want, you can parse the arguments from @_, which says this is what you got. Exists is a Boolean of whether or not the thing even exists to check, what operator it thinks it's using, and the name of the check, which is very useful for writing diagnostics and just all kinds of useful things from that. But I'm not going to go into too much detail because I want to get to even more advanced stuff. Sets, this was nowhere to be seen in test more, but you can check, hey, is this in this set? Is this thing not in this set? Oh, and by the way, you can use the match, mismatch, or whatever other checks you want in your sets. It just works. Back to array. We already saw this once, that you got the array to check, and then here you're specifying, hey, first item, foo, second item should match this regex, but then we're going to jump ahead. We don't care about item 2, so we're jumping right to item 3. So remember, 0, 1, 2 is missing, now 3. You can specify which index you want it to be. So we're checking 3. That, at this point, we just don't care what item at index 2 is. And then end. There should be nothing after 3, so our array should only have 4 items in total. And in this case, let's switch that first one to this one and see our diagnostics. Once again, really helpful. 0, it's bad, but we wanted foo at line 4. Oops, doesn't match our regex that needs an A. And oh, look, we got no, we're missing item 3. We should have bat. Nice diagnostics. Moving on, hash is the same thing, but you specify with field. And it's basically the same thing. I'm not going to keep going because I think you're already sold on that diagnostics. Meta. We're going a bit deeper here. Is thing meta. It should have the property that it is blessed to this module. It should be a hash ref type of size 4, which is the number of keys in the hash or the number of elements in an array. And this is a way for you to take the thing again. So you can say, oh, but this whole thing should also match this check, which can be another deep check if you want. At this point, though, note you might be getting a little crazy and you might want to back out and think of a better way to do it. Ultimately, the reason I have all these is so that you can pick what is going to be the most descriptive. You can group your testing however you want, and you can write it in whatever way you think will be most clear to the next person to read it. You have to make that call, though. Is using something like meta and doing a deep structure going to be the most clear to the next person? Or is it going to be more clear if you do is 5 times? The reason, or a reason to do the deep structure, though, is you get one diagnostic message for all the failures in it. If you call is 4 times and the thing's totally wrong, you will get 4 different diagnostics messages, and you won't necessarily know, oh, did one test break? Did 2 break? Oh, no. With this, you know, oh, only one object was broken. And moving on to object check, which I probably should have done before this, you can do an object check. Check, it's got all the meta properties that it's blessed. Then field, check that the hash ref of this object has these. But also, let's call the foo method to make sure it has this result. Or let's call this custom sub, since the sub we want to check returns a list, not a single item, and check that that sub we defined on the fly will return what we think here. So this lets you do much better checking of objects than isDeeply did, because isDeeply could only check the underlying hash. This lets you call the methods and do the hash, and you tell it which one. Any questions about the compare stuff before I move on?
What does the output look like when one page or one line page?
It's going to look just like the other diagnostics. If there's time at the end, we can start plugging in custom ones and seeing what the diagnostics are.
On the object, is there a way to pass in a parameter to say the new that would be appropriate for that object?
New?
When you have a new, like the instantiator for this object, a new call.
If you called new in this, you'd probably be asking for trouble. I did not get that insane. Anything else? Okay, defer. I added this because I needed it in the Test2 suite to test itself. I needed to test some conditions before I even loaded Test2. So this tool lets you do that. I'm not going to get too deep into this because I'm at halftime and I want to get going to some more advanced stuff. So encoding. Anyone here who's ever tried to use Utf-8 and test more before, you probably gave up. This is how you set encoding now. Really easy. Works everywhere. Exceptions. Most of you have used test exception, test warnings. Really, you shouldn't use those. Instead, you should use, I can't remember what it's called. Rick wrote it. I think he was in the back there. But anyway, you capture the exception and then do the like or the comparison. And same thing with warnings. And that's important because if your warning produces a stack trace, the stack trace will compare the regex, or will have the regex that you're trying to match against in it, and regexes will usually match themselves. So you can get false passes and all kinds of nightmares. So instead you use the dies function to capture your exception. And I'm really going to pick up the pace here. There's tools for checking exports. Imported OK and not imported OK. This is different than is OK because the the function actually has to be defined in your namespace. It will not look in base classes, which is very important when you're checking imports and exports. Tools for checking refs. You got ref OK, ref is, and ref is not, which I put the wrong example there. Subtests are still here, but there's two types. There's buffered subtests, which is new, which actually renders your subtest in a way that kind of makes sense, and it outputs all of this at the end instead of each one going. But you can also use the old test more style subtests, which are harder to read. Warnings, same thing as die, except there's a whole bunch more tools. I recommend you look at them, but I am going to gloss over them until questions at the end. Plugins. Test2 has the concept of plugins. These are things that globally affect behavior for your whole test. They don't necessarily create events, but they change things. Most requested thing in test builder history, from my experience, is bail on fail or die on fail. That is, make your test just stop once something fails. Don't keep trying to go. This was not possible to do in test builder because diagnostics and checking if something was okay were two different functions. So if you died at okay, your diagnostics would never come out, and you won't know why it failed. So die on fail and bail on fail were really hard problems. Test2 makes this really easy, and it solves it. So you can load these plugins, and it'll just work. Exit summary is just summary of why your test failed. srand. This is a really nice thing to use. It will set your random seed to the current date at the beginning of your test so that on any given day, random behavior, unless it's a hash key thing, will always be identical. So you can reproduce your failures that are a result of randomness. But every day, it'll be a new seed, so running your test continually will still check that, oh, if it's a different seed, yes, things still pass. Utf-8, there is a Utf-8 plugin that is even more thorough than that set encoding I showed you. It'll make everything Utf-8. It brings in the Utf-8 pragma, sets standard error, standard out, and affects any formatter you have at the time. Require stuff, there's tools to say, hey, skip this test unless the system is capable of forking. No, skip in case, unless the system actually has fork, like don't run this on Windows. The reason this is important is because this is everything you have to do to properly check if your system can fork. No one ever gets all that. Usually they stop at config defork, which is not accurate because there are so many things that can make forking fail on your system. Then there's things for checking that you have the right module installed, the right version of Perl, and then also threads, which is just as hard to check for. So these things, you load Test2 require threads, your test will simply not run unless the system has threads. And you don't have to worry about all the gory details. Mocking. Test2 suite comes with a mocking library that is one of the few on CPAN that will not make you want to gouge your eyes out. Because any of you who have had to do mocking in tests, you probably went to CPAN and just cried. So the mocking here uses a control object. This is an object that basically lets you control the mocking. You say, hey, add this method, override this method. Oh, restore that back to what it was a minute ago. Override, then override again, then override again. Oh, go back 2 overrides, please. oh, please restore everything back to the way it was before I started screwing with it. And most importantly, when your control object goes out of scope, your mocking goes away. It is completely restored, so you don't have to worry about your mocking bleeding into your next tests. Here's how you use it. It's complicated. There's some sugar I'm going to show you in a minute. So you've got the mock function, or mock class and mock object, but mock can do both those for you. And you capture the control whenever you use these tools. So here's how you mock class. You say my control mock some package, add these methods, and override these methods. This distinction is important because you don't want to add a method, you don't want to say, hey, add a method and then find, oh, the method was already there. Why was it there? You don't want to override a method only to find, oh, you know what, that method didn't exist, so my override did nothing because you misspelled it. So override will warn you if you try to override a method that doesn't exist. And add will warn you if you try and add a method that already exists, just so you know if you've screwed up your testing somehow. Here, we undefine the mock, and it all goes away. Mocking an object is similarly easy. Now, a mocked object is different than a mocked class, in that you basically give it a hash and say, hey, just bless this to an object. Anything that's stored in this hash, make a method for it. What's more is any method you call on this object, whether it exists now or not, will work and will become a getter or setter for you. So you can just manifest one of these and throw it at a function and say, I don't care what you're doing, here's the object you think you want, just run please. And then you can inspect that object and see what got stored or called on it later. But you can also use add to add specific subs that do exactly what you want. This is basically the I don't give a shit, just work mock. Moving on, after I get some water. So how many people here have used Ruby's RSpec? How many of you have used Fennec? There's a couple. Okay. So this is going to be new to a lot of you. This is a very advanced form of subtest. It also gives you some concurrency things that are nice, which I'll get to. So initial setup, you say, hey, here's a bunch of test blocks. They look basically like subtests. Difference here is that these will be compiled, but they won't actually run until you call done testing. This is the most basic unit, and so you consider each of these a unit, a test block. You can give different parameters to them. Flat means, hey, don't render as a subtest, just render inline. To do. This entire block should be to do, so if anything fails, don't actually fail. Or you can do skip and say, hey, please don't actually run this test block. It might format the hard drive or something. You can say ISO, which means this test needs to be isolated. Please isolate it when you run it, which means it'll fork before running it if it can, and then exit that fork when it's done, or use threads. It'll pick for you based on what's most stable on your system. On Windows, it'll use threads. On Linux, it'll use fork. If neither is available, it'll just skip the test and tell you that it skipped it. Async is similar in you say this test can run concurrently with others. And then if you specify, oh, run 3 test blocks at a time, it can run them in parallel, which is really nice. Describe. This is a way to group your test blocks. You say, oh, describe color, test red, test green, test blue, and give them each a block. Size, small, medium, large, give them each a block. You can nest describes. And that's just a way to group them, which becomes important when you then have your before alls. Before all, run this. Before each, run this. The before all will run at the beginning of your describe, then all your test blocks will run. The before each will run once per test block just before the test block. So it's a way to set up conditions or reset conditions. We've also got after all, and after each. Note, you can put the afters, the describes, and the tests in any order you want because it gets compiled and run at done testing. So you don't have to put them all in order or before or after things. Before and after can just go at the top. And that was a very poor way to word that. Okay, you got around. This is good if you want to localize the environment variables for each test, for instance. You just say, oh, continue, or here's my continue. Let's localize environment. Let's run that continue, and now we're done. Got cases. This is to multiply your tests. We got test validator and test visible, and we've got the red, green, and blue cases. this will run 6 test blocks. 6. For red, it'll run both validator and visible. For green, it will run validator and visible. Note C is outside here. It's a closure, so first red will set C to red. Then you validate the color red. Then green will set the color to green. Validator will validate the color green. That's the way it works. So you can do tons of test cases. This gets really useful. So here's the output from that. Actually, did I miss? I might have messed up that. Oh well. So there are case modifiers too. You can say before case, after case, around case. Question? Yes. Concurrency and a few other really nice things, which I might have glossed over. Another benefit here, these test blocks, you can run specific one. You can say, oh, run my test, but only run this test block. Run my test, but only run this describe. Run this test, but only run this case. And it is smart enough to figure out all the combining so that all your befores and afters and cases run properly to give you that one. And for editor integration, you can specify which one to run by giving it any line number that the function declaration spans. So I've got it in Vim, I can just press like F7, and it'll run whatever test block my cursor is in, and only that test block. The rest won't run, which is really nice if your test takes 10 minutes to run, but you only care about one little part. Mocking. I note the control object that I mentioned before. If you are using the spec tools, you do not need to capture the mock here because it'll just be treated as a before each, which is really nice. There's declarative syntax plugin so that you don't have to worry about the trailing semicolon and the sub keyword. We use this at DreamHost, who, by the way, sponsored my trip here, I forgot to mention, and we love it. It is really nice. Note that it looks just like you're declaring a function. You give it your name, and then you give it whatever parameters you want, and then your block. It works just like declaring a sub. Questions about the spec tools? Who thinks this would be useful? Okay, cool. Now, bundles, so bundle is basically where you take a bunch of plugins and a bunch of tools and you put them all into one dist so that you have one thing to load in boilerplate instead of 1,000. There's the extended bundle, which loads this giant list of stuff. There's the more bundle, which tries to emulate test more. Here's the differences. Use OK is gone, require OK is gone, to do skip's gone, these are all gone, explain's gone, new OK is gone. Is OK is different. Is deeply has the new diagnostics instead of the old, and the to-do variable's gone and use the function instead. So it's very close to test more. It's an easy upgrade path if you want to modify an old test but get the better diagnostics. And then there's simple, which you're not going to use because it just gives you OK in planning. Okay, someone had asked about custom events. So this is where we get to some of the nitty-gritty details under the hood. With Test Builder, what you would do is you would grab the global instance, the Test Builder singleton, and you'd call methods on it. That's gone, thank God. The context object is your primary interface into the Test2 internals. Here's how you use it. You write your test function. One of the earliest things you should do is say, hey, give me a context, which comes from Test2 API. Great, you've got a context object. Hey, context OK. We just generated an OK event. Context release, you always release a context when you're done with it. This is how the die on fail works. Because you can't die in a destructor, we have to manually call release. There's a lot of behaviors that are not possible if we were to rely on the object being destroyed. So you have to call release when you're done with it. That might change when Perl gets fixed about dying in a destructor. We'll see. 10 commandments of your context. Get it as early as possible, release it as late as possible. Do not forget to release it. Each sub should get its own context. You do not pass the contexts around. You do not cache them to use later. You do not share them. Basically, your function gets a context. It belongs to that function. Do not give it to another function. It won't work right. Let's see. Do not alter the internals and do not monkey patch the thing. If you need something added to it, talk to me. I'd be happy to add it. Yes, I actually do maintain the shit I write, so you can get new behaviors if you ask for them and they are sane. There is also a lot of protections in here. If you break most of these commandments, it will throw a big nasty warning at you and tell you, hey, you screwed up. These are attributes on the context. Attributes on, wait. I think I screwed up a slide. Please ignore that. Okay, here's the events, the quick events that you can generate with the context. You can generate an OK event. Note the diagnostics are actually tied to the event. You can send a note, which is a diagnostics to standard out, diag, which is diagnostics to standard error, plan, skip, bail. These are all very similar to their test builder interfaces, so anyone who's used test builder will recognize these. And if you want to generate an event type that doesn't have a shortcut, you can use the send event or build event shortcuts. The reason you want to use the context to build your events is because it knows what line number and file name errors should be reported to, and it has a lot of other context that you might not have when you want to send the event. It makes sure that it's right. And you can create custom event types. The event API is really nice. There's some things that all events should have, and you can create your own custom ones. And feel free to use the test2 event : whatever namespace. It's available to you to create your event types. Now going back, here's all the attributes that an event has. It's got a trace, file, line number, all that, whether or not it causes a failure, whether or not it should increase the test count when it comes through, whether or not it's diagnostics in nature, should it be displayed, should there be some behavior after it gets through the whole chain of event sending, terminate, should this one totally exit the test, like, I don't know, bailout. Global, this is only important if you're getting into IPC. A global event is sent to every process and thread at once. Sets plan, and a summary, which is your human readable description of that event. Now I've gone through all my slides, so I'm happy to jump around to any section for any questions.
This may not be directly related, but let's say that you have a test package based on test builder. What would be a good place to look for information on it?
As soon as I finish it, the Test2 manual, which this is actually a part of, this is the manual for people who are using it to write tests. I am working on the part for people who want to write tools, and this I've actually got a Perl Foundation grant for, and I'm hoping to finish that up sometime in the next month or two. There's also the technical documentation, which is all complete. If you go to CPAN or MetaCPAN and look up Test2, it is very well documented as far as every module in the package has documentation and explains all the methods. But that's still not necessarily a complete picture like this manual will provide. But there's also plenty of examples. If you get the Test2 suite distribution, which has all these tools I've been presenting here, you can look at the examples in there, and they're usually straightforward. I dog-fooded the hell out of all of this, which is why it took 2 years, and at this point it's pretty nice to use. A year and a half ago, I would not have let anyone touch it because I realized how awful it was using it, but right now it is really nice, I think. Back. Can you say that a bit louder?
The mock objects mentioned using hash.
Mhm.
Hashes for objects, you handle non-hash objects.
Are you talking about the compare? Oh, you're talking about the mocking. The mocking by default only recognizes hashes for objects, but it's made pretty generically, so you can probably extend it to do arrays or whatever else very easily. The compare doesn't care what the underlying is. You can, like with the compare tool, you can use item or you can use field, and whichever one you use will determine which one it thinks the object is. Yes?
How much, if any, of the underlying code, like the DSL stuff, is available outside the test namespace? Because it could be really useful in runtime.
That has actually been brought up before. There's someone who was an early adopter of this who actually put in a bug request for that on CPAN because he likes the compare tools so much he wants to use them for like validating web input or things like that. They're not, they're under the Test2 namespace, but they're still very usable even outside that namespace. So they'd work. If you wanted to work on porting them out of the namespace in a way where they share the underlying representation, I would be happy to support that. I just don't have time to do it right now.
When you were
There is none. If you're talking about the test blocks, let me go back to that. I've got 5 minutes left. There's an environment variable you specify. And so you'd assign a line number or a file name and line number or the name of the block to this variable and then run prove or Perl or whatever else to run your test, and it will only run the test block you care about. But for specific test numbers, there's no such thing.
Regarding the array tests you were showing before, where you had item specifiers, you had a few in sequence and then one which specified the index.
Yes.
If you then specify another item after item 3, does that?
It'll become 4. It'll be 4. You have to do this in order. Anything after you specify 1, it continues to now 4, 5, 6.
If I had item 3 and then item 2, that.
It would tell you don't do that.
Your events seem to be rather atomic. Is there any support for begin and end events?
Say that one more time.
Your events seem to be rather atomic. Is there any support for begin or end events?
Instead of making those events, they are hooks into the Test2 API itself, because those are more appropriate on some other underlying structures instead of events. Like plugins, like the SRAND plugin makes use of these hooks to make sure it's one of the first things that gets done. There is a concept of, oh, Test2 is starting up, Test2 has sort of snapped into its final state, and there's hooks all through the thing. There's also hooks for when you obtain or release a context. That's the more appropriate place for behaviors that need those. So there is no begin or end event. Any other questions?
You had a link to this at the beginning. I was just wondering what happened. Share that again.
Yep, there it is. Okay. Well, and then I think that is the end. Thank you. Please feel free to hit me up around the conference. I like talking about these things. I like working one-on-one with people. Also, report bugs on GitHub, wherever else.